Problems on trains, section 1. We do gotta understand the term relative velocity first. So let's spend some time in understanding that. I have created a little setup with two dots A and B and a lot of white space. And you would notice that dots are moving with same speed, let's say 2 meters per second. Suddenly, the speed of the particle A doubles. Now let me present you with two arguments, and you have to pick the one which is right. The first argument is that the speed of the particle A increased to 2 meters per second, and the second argument is no, it increased to 4 meters per second. Which one is right? You see, it's not just enough, to say only speed. You have to combine it with respect to what? If you say it's 4 meters per second with respect to camera, then you're dead right, because that poor particle B would argue that it's 2 meters per second because that's what it sees. So what have we got from all this? You have to pick a frame of reference to make sense, and that's what we will do in section 2. So problem 1. A man is standing on a railway bridge which is 180 meters long. He finds that a train crosses the bridge in 20 seconds but himself in 8 seconds. Find the length of the train and its speed. First, let's assume the man was at the end of the bridge. Surely you can assume his place to be anywhere, and let's choose bridge as our frame of reference. Now back to problem. He says a train crosses a man on the bridge and bridge in 8 seconds and 20 seconds, which also mean it took 20 seconds to cover the train's length, let's say x plus bridge's length, and only took 8 seconds to cover its length. Now as the speed doesn't change, we can equate both those speeds and solve for x. And upon getting x, just substitute it back to get speed. Problem 2. Two trains, 137 meters and 163 meters in length, are running towards each other on parallel lines. One at the rate of 42 km per hour and other at 48 km per hour. In what time will they be clear of each other from the moment they meet? Step 1. Laying out the picture. But before that, let's straighten out few things. We will pick any one of those trains as our frame of reference. If we do that, we have to change few things because the data in the question is with respect to ground. Now if we pick any train, the other train will seem to come closer with the speed 90 km per hour. From the frame of reference of the trains, the data with respect to ground add up when they move in opposite direction to each other and get subtracted when they are moving in same direction. Thing to note here is that the speed of approach or speed of separation remains the same regardless of any frame of reference. Okay, back to laying out the picture. We are now in the frame of reference of train, so one seems to be not moving at all while other moves with the speed of approach. Here it's 90 km per hour. Step 2. Find the relation and solve. So we got the speed and we know the distance. Just divide them to get the answer. So go on, give it a try. And if you're new to this series, please look in the description. There will be a playlist containing all the videos in this series for you to follow along.